So hello everyone, welcome to our channel Tech Talks, and if you are new to our channel, please subscribe our channel for more updates. In the previous video, we have talked about how to find the largest element from the array, and in this video, we will check if an array is sorted or not. It's a very easy questions. So let me open an online compiler. So here we have been given a array. We have to check whether the array is sorted or not. So there are some of the constraints we are considering here. The array is having unique elements only, and the array is, we have to check whether the array is sorted in ascending order or not. We are considering the ascending order case only. Okay. So what will the brute force approach? Brute force approach will be I will pick a element and I will check on the right side of the element if the all the element is greater than that element or not. If it is greater than that element, then it's okay. If not, then the array is not sorted. Okay. For that, I will take n variable in which I will store the length of the array. Then I will iterate through a loop. And I is equal to 0, I less than n, I plus plus. Okay. I will store my current, means I am checking for the current element. ARR of I is my current element, for which element I am checking. Okay. I will run a loop from the next element, and j is equal to I plus 1. Our current element is at ith index, then I am checking from I plus 1th index. Okay. J is less than n, j plus plus. If my current is less than ARR of j, means this is a safe side, means the array is sorted. But if current is less and ARR of j is greater, then it's the safe side. But if my current becomes greater than ARR of j, then I will simply print ln sorry system dot out dot println false. I'll simply print it, and from here I will return. Okay. If not, if not this case, then our loop will run successfully, means the array is sorted. So I will simply print system dot out dot println true. Okay. This is the case. Or in this case it will, I guess, print false true. No, it's not printing, because from here only it's returning, right? Because in this case 1 2 good, no issues, 1 2 3 good, no issues, 1 2 5 3 5 no issues. Here the case comes where our current element is greater than the next element, means right hand side the element, one of the right hand side element is less than our current element. That's why it's returning false. Let me check it once for this. I will run it. It's returning true. So it's working. So now analyze the time complexity of this. Time complexity of this will be big O of n square. Big O of n into n. Okay, because I am using a nested loop. Space complexity, what is less, what will be the space complexity? Since I am not using any extra space, so it will be constant. Okay. Can we optimize it? Yes. How can you optimize it? For every element I am checking the right hand side. For this element also I am checking this. For this element also I am checking these again. So I will optimize it. How I can optimize it? Check. Let me show you. So we have this. We will run a loop for int I is equal to 0, I is less than n, I plus plus. Okay, we'll run a loop till n. Now I will check if my ARR of I means the element which for which I am checking, the current element is less is greater than ARR of I plus 1. Okay, there is an error in this code. I will show you so that we can learn together. I will simply print system.out.println false, because if ARR of I means our current element is greater, becoming greater than the next element, that is the false condition, because our array is sorted in ascending order. That's why then we will return here from here. Okay, else we will, if the traversing is done completely with no issues, if it does not hit this base case, then we will say that our array is sorted. So we will simply print system.out.println true, means our array is sorted, there is no issue. Now what will with the error, let me show you. The error is array index out of bound, because I am taking I plus 1 and I am running the loop from I 0 to n means n minus 1, less than n means n minus 1. So n minus 1 is the last index, and for the last index, if I is equal to n minus 1, I will be n, which is not existing in our array. So I will simply minus 1 from here. Now it will run correctly. True. Because our array is sorted, let me check for unsorted array. It should return true. False, sorry. It should return false because it's on unsorted. So we will analyze the time complexity, whether we have optimized it or not. The time complexity for this array is O of n, and space complexity for this is O of 1, because we are not using any extra space, so it's constant space complexity, so we have optimized it. In the previous algorithm, we were taking a nested loop, which was increasing our time complexity. It was n square. Now we have reduced this to n. Okay, so we have optimized it, and the space complexity remains same. So this is the brute force and optimal solution for checking whether the array is sorted or not. If you have any approach, do comment below, and if you have any doubt, do comment below. Thank you.